How do electrical switchgear designs handle system failures with redundancy? Imagine a power grid that keeps running smoothly even if part of it encounters a problem. That's what redundancy in switchgear systems is all about. When you think of switchgear, picture a set of switches, circuit breakers, and relays working together to control and protect electrical equipment. They are the gatekeepers of power systems, making sure everything runs safely. But what happens if a component fails? That's where redundancy comes in. Switchgear designs include backup components that can take over instantly if the primary ones fail. For example, protection relays are duplicated so that if one relay stops working, the other can still detect faults and trip the breaker. This prevents power outages and keeps the system safe. Similarly, trip circuits and control wiring are built with redundancy. If one wiring path or trip coil fails, the backup wiring can still trip the breaker and clear the fault. This setup is essential for reliable fault clearing. Instrument transformers like current transformers and potential transformers are also duplicated. They provide measurements to protection relays. If one transformer fails, the backup transformer continues to supply accurate data, ensuring protection remains active. Automatic transfer schemes are another key feature. They switch loads from a failed power source to a healthy one without manual help. This is common in critical facilities like hospitals or data centers, where continuous power is vital. Protection zones are designed so faults are isolated locally. Multiple relays coordinate to make sure only the affected section is disconnected. This increases system availability and reduces unnecessary outages. Modern switchgear also uses smart relays and communication protocols. These smart devices detect failures quickly and switch to backup equipment automatically, reducing downtime. Designs often follow redundancy models like N+1 or 2N in N+1. There is one extra component beyond what is needed. In 2N, a complete duplicate system exists. For example, a 2N setup means a full backup of the entire switchgear system is ready to take over instantly if a failure occurs. In power systems and renewable energy setups, redundancy keeps everything running smoothly. Redundant relays and transformers help maintain protection even during maintenance or partial failures. In critical places like hospitals or data centers, switchgear with full redundancy ensures continuous power supply. Renewable energy systems also benefit from these schemes to handle variability and keep the grid stable during faults. In short, switchgear designs handle failures by adding multiple layers of backup components. These redundancies make sure that no single failure can stop the flow of electricity. They keep the system safe, reliable, and ready to respond quickly to any problems.